Dear friends, Maths Aspirants is an initiative by myself started in 2017 as a WhatsApp group, as a discussion platform for math lovers, especially for those who are planning to do higher mathematics. Uh, Later in the COVID time, we have started online problem solving sessions series as well as online test series, and also started to conduct national webinars by expert faculties from India and abroad. As a part of the online problem solving session series, today we have a special session focusing on IIT JAM examination, and we blessed to have Ms. Unnati Shukla as a resource person for today's session. Ms. Unnati just completed M.Tech in data analytics from IIT ISM Dhanbad. She did her M.Sc in mathematics and computer science from Maharshi Dayanand University, Rohtak, Haryana. She qualified IIT JAM examination with All India rank 31 and NET examination with All India rank 39 and GATE examination with All India rank 77. So, and also she is very like to teach students. She is running a YouTube channel in which you can see many lectures for JAM and NET aspirants. And also, Ms. Unnati is a very active member of Math Aspirants group, and also she is a contributor for many of our programs. I am sure that today's session will be really very helpful to those who are seriously wish to prepare for the forthcoming IIT JAM examination. Actually, even though the session is being named as Focus on IIT JAM, this will be equally beneficial for anyone who is wish to prepare for any exams like CSIR, NET or GATE. And we will focus more on problems from IIT JAM, but these type of questions will be in the other exams as well. So I'm sure that today's session will be very beneficial to all of you. So I welcome everyone to this program, and I would like to express my sincere gratitude to Ms. Unnati for being with Math Aspirants. I welcome everyone. Welcome, Unnati.
Thank you, sir. I hope I'm audible clearly.
Yes.
Yes, sir. Thank you, sir. It's my pleasure to be here again. And today's session is going to be about the basic problems of IIT JAM. In the latest IIT JAM exams related to differential calculus, function of one variable. Okay, so we are going to see the basic problems and we are going to solve them. So let us begin. Okay, so this is the basic syllabus for function of one real variable, limit, continuity, intermediate value property, differentiation, Rolle's theorem, mean value theorem, L'Hopital's rule, Taylor's theorem, Riemann integration, and so on. So we are not going to cover all the topics because we are, limited in time. But yes, in the further sessions, I hope to cover most of these topics through the problems that we are going to take. Okay, so here's the first problem from 2023 exam. As you can see, this is a limit problem. Let me rewrite it for you. So this is limit. We are asking limit a approaching to 0. And we have two integrals in the numerator and the denominator. 0 to a sine x square dx and divided by 0 to a ln of x plus 1 whole square dx. Okay. So now how to solve for this problem? So if I put directly a as 0, if a approaches to 0, so a is in the limit portion. So when a will approach to 0, we can clearly see that this integral in the numerator and this in the denominator will be 0. So it will be like a 0 by 0 form. So how to approach this question? A very simple way to approach this question is to use Leibniz rule. I hope you all have studied the Leibniz rule for differentiation. So what does it say? That we can differentiate any function which is inside the integral. So how do we do it? See, first of all, we differentiate the numerator. So to differentiate the numerator, we can just differentiate it cos of x square, and then the derivative of x square is 2x, and then we put the limit x is equals to a sine of a square in the function, which is sine x square. And then what we do is we take the derivative of this limit with respect to x, and then we do the same for the lower limit. The lower limit is 0, so we put x is equals to 0, and then we do d by dx of 0. So clearly these two are constant limits, so these two terms are going to be 0. So no need to write them even. And in the denominator, we can see there is ln of x plus 1 whole square. So yes, you can write ln of x plus 1 whole square as, this is whole square of ln x. So this will be 2 times ln of x plus 1. And then you substitute x equals to a, same process, ln of a plus 1 d by dx of this limit, which is a, minus ln of 0 plus 1 whole squared. Okay. I hope you get the idea. We don't need to even write these because we know the constants have 0 differentiation. So these will be 0. And now here it was limit a approaching to 0. So in the numerator, I will get 2x cos x square divided by 2 ln x plus 1. And then we substitute. Okay, sorry. Here we put x is equals to a as limit. So when I do that, this will be, just a minute. I will have to substitute x is equals to a. Then after that, I will get 2a cos a square divided by 2. You can solve with me. I hope you must have got the answer till now. Ln of a plus 1, right? So now again, this is a 0 by 0 form. So again, what we do is we differentiate again. But here I forgot to differentiate ln of x plus 1. See, I made a mistake. Ln of x plus 1 whole square was given. So I had to apply the chain rule. So I did 2 times of ln x plus 1. And then I had to multiply it with the derivative of ln x plus 1, which was 1 by x plus 1. So it will be multiplied with 1 by x plus 1, or I would say 1 by a plus 1 now. Right? So it will become a over a plus 1 into cos a square divided by ln of a plus 1. Limit a approaching to 0. Now let's see what happens now. So you can, what you can do is, you can make these two limits, calculate these two limits differently. Multiplication of two limits, it is a by a plus 1. It is 0 into, so this is again 0 by 0 form. So it will be.
Ma'am, I have a doubt.
Yes.
Will that a plus 1 come in the numerator?
Oh, yeah. That's where I made a mistake. Sorry. So this will be 1 by a plus 1. Okay, so it will be will be a into a plus 1 cos a square divided by ln of a plus 1. All right. Now what we can do is ln of this thing. Now this is again a 0 by 0 form, so we'll again have to differentiate. Numerator, this is 0, and this is 1, and this is again 0. So we will again have to differentiate. So what we can do is a into a plus 1, we can apply u into v rule, or maybe we could just, separate these two limits. Ln of a plus 1 by a. We could have done this. See, what is this limit? I want to ask you, what is this limit? Limit a approaching to 0, ln of a plus 1 over a. Can you find this limit? This is a 0 by 0 form, but when you apply L'Hopital's rule, what happens is you differentiate the numerator and you differentiate the denominator. What you get is 1. So I can say that this limit is going to be a upon this limit is going to be 1. All right, this is 1. And what about this limit? This limit is going to be 0 plus 1, 1 into cos 0, which is 1. So both of these limits are 1. So you don't have to again differentiate. There is an easy way to do it. So what we did is, in short, what we did is we solved for a over ln of a plus 1. We know the value of this limit. And again, we know the value of this limit also. A plus 1 into cos a square. Both of these limits are 1. So the answer that we are going to get is 1 into 1. So 1 into 1. So the answer for this question is 1. You can solve this question in 2 minutes. We made mistakes and we were trying to figure out the question. So that's why we took time. But overall, this question will not take more than 2 minutes. And these type of questions wherein integrals are included, you need to understand that you should be using the Leibniz rule of differentiation. Because whenever limit and integral is given, you just directly put the limit and you see there is 0 by 0 form or infinity by infinity form. You can apply Leibniz rule and then you can get rid of the integrals. Once you get rid of the integrals, you can just solve it again if there is a 0 by 0 form, or you can just directly calculate the limit. So that is how it works. Okay. So let's move on to the next question. You can take any of your doubts by the end of this session. See, this is an interesting question, and this question was, I don't know, I don't remember, maybe in some year this was asked in CSIR NET also. Similar type of question. So f is a function from r square to r square, they are saying, and f of xy is a function of two variables, and it is defined as, let us write f of xy. F of xy is defined as e power x to cos y, e power x times sin y. And the question is to find the number of points in R square that do not lie in the range of f. How many points do not belong to the range of f? That's what they are asking. So how do we do this question is, we need to find the range of f. So this is our range of f. So see, there is one thing to note here, is that cos y and sin y, both of these are bounded functions. But they can take values from -1 to 1. And this right here, e power x, this is an unbounded function. And this can take any value from 0 to infinity. This will not take the 0 value. So if you want to consider any value, let's say I want some value a, I want some value a to be here, and some value b to be here. Let's say if I want a value, some constant a on the left hand side, then a will be obtained with the help of e raised to power x cos y. So how will I obtain this a? Let's say this a is, 1117.1. How do I obtain this? See, what you can do is you can obtain this value by, let's say, if you consider y is equals to pi by 4. Can you do that? Yes, because y belongs to R. X also belongs to whole R. So if I put y is equals to pi by 4, then e power x into cos pi by 4 will be 1017 something, whatever it is, like this. So e power x will be 1017.1 into cos pi by 4 is 1 by root 2. So this will be square root of 2 multiplied. So you will have to choose some x so that you get e power x as 1017.1 into root 2. I don't know what this value is going to be, but I'm sure that I can find an x so that I obtain this value. Why did I took this number? This might confuse you. I'm just trying to explain from the very basic that any value you take, be it 1017 or any negative value, let's say it was a negative value. If it was a negative value, then I would have taken this as cos 3 pi by 4. Cos 3 pi by 4 would have given me like negative root 2 something. So I would have made this negative. But the point is, I need to find an x so that I get this value in return. Can I do that? Of course I can, because e power x is an unbounded function. Starting from 0, it goes up to infinity. And you need to understand that I can find an x value, I don't know, somewhere here or somewhere here, an x value that could give me, e power x as this. Okay. Am I still audible?
Yes, ma'am.
Yes, someone has raised their hand. Yes, please ask the question, because we are limited in time. Yes, please. Okay. I think this was by mistake. Okay, so this is the idea. But what if I want to get some value in the range, something like, a comma 0. Can I get this? Yes, I can get this. For that, I need to have this to be ex cos y. I can get this value as a. And for that, I need to have sine y to be, this value to be 0. The right hand side to be 0. And for the right hand side to be 0, I need to put y is equals to 0 or pi or 2 pi or 3 pi. E power x value can be, x value can be anything, but to put, to get this value as 0, I should put sine y as, y as these values. But what if I want to get this value in the range? Can I get this value in the range? Let us see. We are just observing this question. E raised to power x cos y. So is there any issue? I'm getting notifications again and again.
No, Unnati, you can continue.
Yeah. So I want to get this value. Can I get this value 0, 0? With the help of this, let's see. See, e power x is never 0. E power x is never 0. So whatever which is going to make it 0 will be cos y and sine y. So I want that cos y is 0 to make this left hand 0. And to make this right hand coordinate 0, I want that sine y is also equal to 0. So can I get some y for which, cos y and sine y both are 0 at the same time? See, there is no y in this world for which you get cos y and sine y to be 0 at the same time. Sine y will be 0 at n pi's. This is for sine y to be 0. And for cos y to be 0, you will have to have, y is to be of this form. So there is no intersection between the two. So if you want to get this value 0, 0 in the range, you will never get it. Okay. This all is dependent on the y values, because x values are never 0. E power x is never 0. Okay. So this value is excluded from the range, number one. Second point is, to obtain any other value than this value, the value could be of the form a, the value could be of the form some ab, where a is not equal to b. A is non-zero here. A is non-zero. B is non-zero. Your value could be of the form a0, where a is non-zero, and your value could be of the form b non-zero. Okay. These 4 type of values you can check by yourself. I've given you the idea. Now your task is to, use your mind and, figure out how to get all these 4 types of values. How can you get the same non-zero value at both parts? To get a value like this, I'm giving you a hint. To get a value like this, e to the power x cos y should be equal to some a, and e to the power x sin y should be equal to some a. That means, cos y should be equal to a into e raised to power minus x, and sin y should also be equal to a into e raised to power minus x. So that means, cos y and sin y should be somehow equal. Yes, they are equal, and at a value which is pi by 4 plus, something n pi or 2n pi. Yes, something like that. So you can get cos y and sin y to be equal in this case. But the problem was only at this point, the origin. You can't get origin, because cos y and sin y can attain a value, 1 by root 2 at the same time, or some other value, but they cannot obtain, 0 value at the same time. So the only point that can be excluded, or that cannot be attained in the range, is just one point, which is this point. So the answer is, this point cannot be obtained. The set is this. So they are asking you to find the number of points that do not lie in the range. This is one point I got that did not lie in the range. So my answer would be 1. Other than that, it's up to you. You can check any point you take in the world. You can always get an x and y to obtain that point with the help of this, function. Okay, but just the problem was with this point origin. Okay, let's move on to next page. I hope we are clear till now. I haven't included much number of questions because we are limited in time, but yes, we are going to continue from the next sessions, so don't worry. Okay, let's see this question. Read out this question number 25. So they are asking you that f of x is equals to cos x, g of x is equals to 1 minus x square by 2. So f of x is equals to cos x, g of x is equals to 1 minus x square by 2. Just a minute. Now they are asking, for x belongs to minus pi by 2 to pi by 2, f of x is greater than equal to g of x, or f of x is less than equal to g of x, or fx minus gx changes sign exactly once. So what should be the answer? They are asking. So now, for doing these type of questions, we can use the idea of increasing decreasing functions. Let us see. Now, if f of x is equals to cos x, let me suppose hx is equals to f of x minus g of x. Okay. Let's see if that can help me. If I am able to prove that h dash x is greater than equal to 0 for all x greater than 0, then I will be able to prove that this function is strictly increasing or monotonically increasing function. Then in that case, I will get that hx will be greater than equal to 0 for all x greater than 0. Let us work it out and let's see how it works. So hx will be cos x minus gx. Gx will be 1 minus x square by 2. And then this is equals to cos x minus 1 plus x square by 2. What is h dash x? H dash x is minus sin x plus x. And what is that we know about sin x and x? Which is greater, sin x or x? Our range of interval is minus pi by 2 to pi by 2. So sin x is something like this in this interval. This is 1. Okay, this is minus 1. So sin x in this interval, minus pi by 2 to pi by 2, sin x is always less than equals to x. Just give me a minute. We are running out of space. So in this interval, you can see with the help of graph. This is a very basic, calculus thing, that sin x is always less than equal to x in this interval. So this right here will always be sin x, as sin x is less than equals to x, so this will always be greater than equal to 0. So that means that h dash x is greater than equal to 0 for all x belongs to minus pi by 2 to pi by 2. Okay, now hx is f of x minus g of x. So here what we can see, what is the meaning of monotonically increasing function? Hx is monotonically increasing by this idea, monotonically increasing function. What is the meaning of monotonically increasing function? That if x is greater than y, we will get some hx is monotonically increasing, then x greater than y implies hx is greater than equal to hy. Okay. So we are asked f of x minus g of x, what is greater? Fx is greater or gx is greater? And we have supposed that hx is equals to fx minus gx, right? In this interval. Okay. So as h dash x is greater than equal to 0, so we will get hx will be, let's see, what is h0? We need to find h0. Can we find h0? Yes, we can. h0 is equals to f of 0 minus g of 0. So f of 0 is cos 0, which is 1. G of 0 is 1 minus 0 by 2. So 1 minus 1. F of 0 minus g of 0 will be 0. Okay. Cos x minus 1 plus x square by 2. You can substitute x equal to 0 here. So you get h of 0 to be 0. So hx is always h dash x. Hx will be always greater than equal to h0. This will be true for all x greater than equal to 0. So this implies this was true because function was monotonically increasing. So now I can write this as hx was cos x minus 1 plus x square by 2. And now I have proved that this is greater than equal to h0, which is 0. So cos x will be greater than equal to 1 minus x square by 2. So this was f of x and this was g of x. Okay. But for x less than equal to 0, what will happen? This thing was true for x greater than equal to 0. What about for x less than equal to 0. We have solved for x greater than equal to 0. Now we want to solve for x less than equal to 0. So what happens when x is less than equal to 0? It is again strictly increasing function. So monotonically increasing function. Sorry for saying strictly increasing again and again. This is monotonically increasing function. So for x less than equal to 0, that means x lying between -π/2 to 0. Our h of x should be less than equal to h of 0. And what is our h of x? H of x is f of x minus g of x. This should be less than equal to h of 0. H of 0, we have seen that h of 0 is 0. So f of x should be less than equal to g of x in this interval. So we have two cases, -π/2 to 0 and 0 to π/2. In this case, f of x is less than equals to g of x. And in this case, f of x is greater than equal to g of x. Okay, so here that means, it means that h dash x is, h dash x will be, they are asking, let us read the question again. They are asking f of x is greater than equal to g of x in x belongs to -π/2 to π/2. True or not? Yes, we have seen that fx is greater than equal to, see, we solved here, fx was greater than equal to g of x for all x greater than equal to 0. Okay, so the first option is correct. Now what about the second option? They are saying, no, first option is not correct. First option was correct for x greater than equal to 0. So in short, what we have obtained is x greater than equal to 0, we have fx greater than equal to g of x. And x less than equal to 0, we have fx less than equal to g of x. So first option is not correct. For all x, it is not correct. Second is not correct. And the third is fx minus gx changes sign exactly once, or fx minus gx changes sign more than once. So C option will be correct because first fx minus gx was positive. In case 1, this was positive, fx minus g of x. And then it changed the sign to negative. You know, fx minus gx here is less than 0. So it changed sign from positive, it was converted to negative. So the answer should be fx minus gx changes sign exactly once in this interval. First it was positive on the left hand side, and then it changed sign to negative on the right hand side. So answer should be C, and D will be incorrect. Okay, so this was a single correct question. So the idea that we used in this question was, we used the idea of monotonically increasing decreasing function. Secondly, we used the idea of that sin x is always less than equal to x in this interval -π/2 to π/2. And what we did, yeah, these were the basic ideas that we used. So this was a question of monotonically increasing decreasing. Now let's move on to one more interesting question. This was a question in JAM 2023, asked in JAM 2023. Now let's see how to solve this. So we have been given a function f of x is equals to x raised to power 1/3. And we have been given a function theta of h, theta, which is a function of h. And they have given us a relation f of 3 plus h minus f of 3 is equals to h into f dash 3 plus theta times h. And this is true for all h belonging to -1 to 1. Now they are asking, what they are asking us is limit h approaching to 0 theta of h. As theta is a function of h, they want us to evaluate this limit h tends to 0 theta h. So maybe we don't know what theta is, but as we will solve further, we will be able to maybe figure out what theta is and what it is limit. So this question seems somehow something similar to maybe Taylor's theorem or mean value theorem. So what Taylor's theorem says is, if you have a function and it is continuous around a point, and the main point given here is, I hope you remember the statement of Taylor's theorem. If you do not, let me give you a little idea what Taylor theorem says. That the point of continuity, if you know this is a point of continuity, here the main point is x is equals to 3. See, I want to show you one thing. F of x is equals to x raised to power 1 by 3. If you differentiate it, what you will get is 1 by 3 x raised to power minus 2 by 3. So the only point where it might not be differentiable is x is equals to 0. Other than any point x is equals to 0, if you take any non-zero point, this function is going to be very, differentiable and continuous and everything. So the only problem that you are going to face is at this point x equals to 0, because this is negative power. So this function is, you can say, infinitely differentiable at a non-zero point, and the non-zero point given here is x equal to 3. So Taylor's theorem is applicable. What Taylor's theorem says is, if you have a function f and its first derivative and its second derivative and its third derivative and n minus 1 derivatives are continuous, and its nth derivative is, its nth derivative exists, we can see that this is infinitely differentiable function. So its nth derivative exists, its n minus 1 derivatives are continuous. So these conditions are satisfied. Then there exists a theta, that theta, which is a function of h, and that theta lies in 0 to 1. There is a range of theta. Theta lies in 0 to 1, and the condition of Taylor's theorem satisfies. So Taylor's theorem says, if you have n minus 1 derivatives which are continuous, nth derivative which is, which exists, then there exists a theta. So it says, then there exists a theta such that theta is between 0 and 1. Then, your theorem starts at f of 3 plus h is equals to f of 3 plus, h f dash 3 plus h square by 2 f double dash 3 and so on. So the most important point to note here is that theta is between 0 and 1. Theta will be bounded. Okay. Now I'm going to use this condition while solving the question. Let's see how to solve. So the given condition is this. Let me erase this a bit. I hope you are making notes or, noting down, because this is important. Now, what we can do in this question, this is the given statement. This is the given statement. How can we further solve it? Let's see. So I want to put the limit h tends to 0. What if I do something to make, this as like something like this, f of 3 plus theta h minus f dash 3 divided by, theta h something. So this will be, somehow it will be similar to f double dash 3, something like that. I hope you're getting my point. You will understand what I'm trying to say once I make some substitutions. It will be f of 3 plus h minus f of 3. And what I'm going to do is, I'm going to subtract minus h into f dash 3 from both sides. And you will know why in just 1 minute. This will be this. I'm not writing theta h as theta h. I'm just writing theta as theta multiplied by this h. So I'm subtracting h f dash 3 from both sides. And let's see how it works for me. What I can do on the right hand side is, you can clearly see, I can take on the right hand side, I can take h as common. So let me take h as common. What will I get? F dash 3 plus theta h minus F dash 3. Okay. Now it's still not completed. Let's see. How will it further work? On the left hand side, this is the thing. What can I do further? I should divide it by theta h, because I want this term to be in the denominator to make, to make it a full derivative. So I will have to multiply with theta h also, obviously. And now what should I do? I should write this as h, theta h. I should write it as theta h square, into f dash 3 plus theta h minus f dash 3 divided by theta h. Now if I take limit, h tends to 0, or limit theta h tends to 0, then it will be the derivative of f dash. The derivative of f dash is f double dash. So, okay, let's write this again. And let's see what we can do now. Now what I can do is, I can get rid of this theta h square by dividing it on this side. So I will get, I hope I have not made any mistake. I have not made any mistake. Let's see. Just a quick look. Okay, good. Yeah, everything is fine till now. Okay. So let me just divide by h square both sides. Let's see what happens. Let me divide by h square on both sides. What will I get? What will I get? I will get rid of h square on the right hand side. And on the left hand side, what I'm getting is 1 by h. If I take as common, I will get f dash 3 plus h minus f3. F dash, it will not be f dash. F of 3 plus h, yeah. F of 3 plus h, this is. Minus f3 minus f, f dash 3 into h divided by h. Okay. And on the right hand side, I will get theta into, this whole term. So this right here is f of 3 plus h minus f3 divided by h minus, this will be h by h. So this will be f dash 3. And 1 by h will be outside. Or you can just, you can keep it inside also, because then you will have to multiply it again. So let me just, keep it inside. That will be more helpful. So this will be like this, h square. Okay. It is more helpful. And then this, this whole term. So if I put limit h tends to 0 both sides, let's see what happens. Let's see what happens. What happens on the left hand side is, I get f of 3 minus f of 3. This will be 0. And this will be f dash 3, which is some constant, into 0. So 0 minus 0 will be 0, and divided by 0 will be again 0. So it will be 0 by 0 form. So to get rid of the 0 by 0 form, we need L'Hopital's rule. And in order to apply that rule, we should just differentiate on the numerator and denominator. So it will be like this in numerator, and in denominator, it will be like this. And it will be limit h tends to 0, theta into, it was f3 plus theta h minus f3 divided by theta h. So now maybe we are close. close to what we want. Now this right here is f'3, and this is limit h tends to 0 theta, which I don't know what will it be, but I just want its value. And this again right here, it will be 1/2. If I take 1/2 as common, this will again be f'3, right? I hope I'm getting my answer. This will be f'3, f'3. If you find f'3, that will be a non-zero value. You can solve for it. It will be very easy to differentiate x raised to power 1/3 2 times and just put x equal to 3. So now what we get is limit h tends to 0 theta is equals to obviously 1/2. So we got the answer as 1/2 or 0.5. So it will be a numerical answer type question. So yes, it is a numerical answer type question. So you should write 0.5 from your keyboard in the exam. So yeah, it took time, but it wasn't that big question. We kept thinking and we kept figuring out. So how did I figure out what to do in this question? I didn't do anything special in this question. I just made use of one thing, which I didn't actively tell you. I made use of the fact that theta was bounded, and that's why when I did this limit h tends to 0, then this theta h inside, it became 0 because theta was bounded function and h was approaching to 0, so bounded into 0 became 0. So this is one thing I made use of, and another thing I just made the use of definition of derivative, differentiability, left hand right hand derivative kind of thing. That's what I did, nothing special. You could try some another method. So I find this method helpful. You can also try with some other methods when you're practicing. Let's move on to the next page. Let's see what questions we have. This is a repetitive question. Yeah, this is a very nice question. And I want to introduce Riemann integrability with the help of this question to you. If you are not familiar with Riemann integration. Okay, this is a nice question. They are asking which of the following are Riemann integrable question in 01. From the past 2 or 3 years, I think from 2022, IIT JAM has been asking questions and given the syllabus of Riemann integration. So the basic question, basic type that they ask in any exam is which of the following functions are Riemann integrable. This is a type you are going to get in any exam, and it is very easy question. Every time they ask this question is very easy. There are some techniques to find, I will tell you some techniques on how to find a function is Riemann integrable or not. Just give me a minute. I'll give you some 4 or 5 points. If you check those points, you can just tell any function to be Riemann integrable. So try to read out the first question, which is this first function in the form of integration. So let's see how do we solve it. So I want to tell you some 4 or 5 points regarding integration, Riemann integration. See, whenever you read the definition of Riemann integration, it seems like it's difficult to solve questions. But here we will not use definition. We are not using the definition. We are just using the theorems. We are just using some axioms and theorems to, find out whether given function is Riemann integrable or not. The definition of Riemann integration says that the lower integration should be equal to the upper integration, should be equal to the actual integration, something like that. I don't exactly remember, but yeah, somehow it is like this. Upper integral, lower integral should be equal to, this integral. And if this is so, the function will be Riemann integrable. But it is not possible to find upper and lower integral for every function. So how do we solve in exams? It is a different way. So number 1 point to check while checking for Riemann integrability is to check if your function is continuous. So I will say that f, your function f is Riemann integrable in the closed interval. Riemann integrability will also always be asked in closed interval. You know, your function can be integrable only in a closed interval. So it will be Riemann integrable if this is continuous in that interval. Okay. But what if it is not continuous? Will it be Riemann integrable? Yes, it can be. But continuity is a sufficient condition for Riemann integrability. It is not necessary, but it is sufficient. But if your function is not continuous, you can still check for Riemann integrability. Let's see how. So third point before telling the second point is, if your function has finite or rather more general, if your function has countable number of discontinuities. Countable number of discontinuities. But countable number of discontinuities you might not be familiar with. So just use the term if your function has finite number of discontinuities. Because for JAM students, countability and uncountability is a non-familiar topic. So if you're preparing from the point of view of CSIR NET or GATE, you can do the countable definition. But if you're a JAM student preparing for IIT JAM, you just know that if f has finite number of discontinuities, then our function will be Riemann integrable. So if it is continuous, it's good. But if it is not continuous, it can have finite number of discontinuities. Then also we will say that this is Riemann integrable. What if I cannot check for continuity, or it is not continuous, it doesn't have finite discontinuities? What if it has infinite discontinuities? Then it still can be Riemann integrable. So there is one more criteria which says if f is monotone in that interval, then also it will be Riemann integrable. Okay. But a discontinuous function, one thing to note here is that if a function is discontinuous everywhere, then it won't be Riemann integrable. So let's see, we'll apply everything in questions. And yes, we have done each of these points. So if f and g are Riemann integrable, there is one more property which is important regarding to Riemann integrability. It is, if f and g are Riemann integrable in closed interval AB, then alpha f plus beta g, which is the linear combination of these two functions, is also Riemann integrable in the closed interval AB. Okay. If a function is unbounded in that interval, it will not be Riemann integrable. There is one more point which is important, that if f is unbounded, any unbounded function cannot be Riemann integrable. So f is not Riemann integrable, or I can say f does not belong to RAB. So these are some important points. I will share these slides with you, so don't worry about noting them. Okay. So yeah.
Are you doing the next question or the previous question?
I'm doing this question. I'm not doing any question. I'm just explaining you that how to check a function is Riemann integrable or not. Currently,
Okay,
I'm just doing. Yeah.
Actually, like we are seeing the previous question, f of x is equal to x power 1/3. That page we have seen.
Oh,
Are you?
okay. That is maybe some issue. Let me re-share my screen. Wait.
Sure, ma'am.
Now what is visible to you? Okay, my screen is not visible. Just a minute. You should have just said this before, but no issues. Now you might be seeing this Riemann integrable question.
Yes, ma'am.
Sorry for the inconvenience. I'm sorry. I'm really sorry. Okay, now I'll just tell you everything in summary. Okay, which of the following functions are Riemann integrable? So whenever a function of Riemann integrability comes in IIT JAM or in any exam, they will ask you to check the Riemann integrability in a closed interval, closed and bounded interval. So in order for a function to be Riemann integrable, first condition is that it should be bounded. It cannot be an unbounded function. Okay, so in that closed interval, this function will be bounded. So this is the first preliminary condition. Another thing is, any continuous function if they give you, that will always be Riemann integrable. In our lower classes, we have studied that any continuous function is an integrable function. So that is the same idea. So read here, the first point is, f is Riemann integrable in closed interval if f is continuous in AB. If it is continuous, very good. But what if it's not continuous? See the third point. If it is not continuous, then if it has finite number of discontinuities, then it will also be Riemann integrable. But the converse need not be true. So a function with finite number of discontinuities can be Riemann integrable, but a Riemann integrable function may have infinite discontinuities also. Okay, so this is a complex concept, but yes, remember it using just one side. Riemann integrability is implied by continuity or finite number of discontinuities, or if it is monotone in that interval, monotone in that whole interval. Okay, a function which is discontinuous everywhere, it will not be Riemann integrable. Remember that, a point to be noted. And last 2 points are, see, this point is, if f and g both are Riemann integrable, then their linear combination is also Riemann integrable. And the last point is, unbounded function can never be Riemann integrable. These are the some points that you should remember. With the help of these points, you can do any question. So let's do 35th question, which was asked in JAM 2023. So let's come to B point first, then we will see the A point. So part number B. Part number B is this function. Is it a continuous function? Can anybody tell me? We don't need to solve this function. Is it continuous? See, if you see clearly, this function may have any problem at just one point x equals to 0. I hope I am audible. I am audible, I guess. So this function may have problem at just x equal to 0. So let us check its limit at x equals to 0. I'm just solving for part B, okay? Limit x approaching to 0, x sine 1 by x. This is clearly 0 because x tends to 0. This is 0 into bounded is 0. So this is a continuous function. Okay? At x equals to 0, it's limiting and functional value is also 0. So this is a continuous function, and continuity implies Riemann integrability. So this is Riemann integrable. So C part now. Is this Riemann integrable? See, I said that any function which is discontinuous everywhere will not be Riemann integrable. And C part is clearly a function which is discontinuous at every single point in this interval 0, 1. Why? Because this is an example of Dirichlet's function. This function is everywhere discontinuous. So this is not continuous. Sorry, not Riemann integrable. And part D is a very simple function. I want you to tell me part D, what is the point of discontinuity for part D? Is there any point of discontinuity, or is it a continuous function? Anybody answer?
At 1, it is discontinuous.
At 1, it is discontinuous. Other than 1, it is continuous at every point. So this has a finite number of discontinuities. And I told you in the third point here that if a function has finite number of discontinuities, it is continuous. Why I'm not using the countable word here is because JAM students are here mostly. For IIT JAM students, finite will do, finite number of discontinuities, because countability and uncountability, I guess it is not in your syllabus. Countability is for CSIR NET or GATE aspirants. So you just are good with finite number of discontinuities. So this is Riemann integrable. So part A, let us solve it. 0 to x 1 by 2 minus t mod. Okay, let us solve for it. I don't know if it is Riemann integrable or not. 0 to x 1 by 2 minus t dt. So this is our function, 1 by 2 minus t dt. Yes. So this is a modulus function. How to open this function? This function. This will be equal to 1 by 2 minus t if 1 by 2 minus t is greater than equal to 0. And this will be equal to minus 1 by 2 plus t if 1 by 2 minus t is less than equal to 0. Okay. So for t, this is t less than equal to 1 by 2. This is this. So 0 to 1 by 2, this should be half minus t. And from 1 by 2 to, x, it should be t minus half. Can we solve it? It is very easy to solve. So whenever you will solve this, you are going to get a linear function. I don't even need to solve it, but let's just do it for our satisfaction. It will be like this. Then it will be t square by 2, which is x square by 2. T square by 2 minus 1 by 2 t. It will be 1 by 2 to x. Now I think you can solve it. This will be a constant value. And this will be some x square by 2 minus x by 2 minus 1 by 8 plus, 1 by 4, something like that. So this is a polynomial. This is a quadratic polynomial. And what do you know about polynomials? They are always continuous. And a function which is continuous is Riemann integrable. So this will also be Riemann integrable. So yes, A part is also correct. Okay. Now let's move on to the next part. The next question. This was a very easy question. I hope you enjoyed it. And Riemann integrable questions are very interesting and easy. So we are left with 2 questions now. This will take approximately 20-25 minutes. And then we will have a discussion. Okay. Very interesting questions from 2024. So read out this question. Question number 24 from IIT JAM 2024. This IIT JAM 24 exam was very difficult. I think the general cutoff was just 11 point something, which is very low in the recent years. Generally the cutoff is above 20, but this time the cutoff was very low. The paper set by IIT Madras was very difficult. This time IIT Delhi is setting up the paper, and let's hope for the best. Okay. So P statement says there exists a function which is defined from R to R and a function G which is defined from G to G. Okay, sorry. Just a minute. Yeah. And a function G which is defined from R to R such that f is continuous at x is equals to 1. So they have said that f is continuous at this point, x equal to 1. And G is discontinuous at x is equals to 1. G is discontinuous at x equals to 1. But G of f is continuous at x equal to 1. Can anybody confirm that you are seeing the correct screen? Because last time the screen didn't change.
Yes, ma'am.
Okay,
Correct screen.
okay, thank you. So f is continuous. F is function R to R, and it is continuous at x equal to 1. Continuous, okay? But G, they are saying that G is defined from R to R, and this is discontinuous at x equal to 1. But they are saying, this statement says that G of f from R to R will be continuous at x equal to 1. Is it possible? They are asking, is it possible? Any example possible for this? See, G is a discontinuous function. So if, let's say f is like something like this. Let's say f is a continuous function. Let's say f x is equals to 1, a constant function. A constant function is always continuous at all x belongs to R. So, and g of x, let's say kuch aisa we can define like if x is equals to 1, this is, let's say, 1, and for x not equal to 1, let's say this is some 0. Very simple function. Let's see if it can help us, or what we can figure out from these two functions. So if I do G of f now, this is continuous, this is not continuous at x equal to 1. So G of f here is what? Can we compose these two functions? G of f is equals to G of f of x. And f of x here I have taken, for all x belongs to R, it is just 1. So I can write this as G of 1 for all x belongs to R, because my f of x is equals to 1. So G of 1 is always 1. Oh wow, great. So now G of f we got is x is equals to 1. So I was just experimenting with functions. What I was trying to do is, whenever they ask you to take one continuous function and one discontinuous function, what you should think about is that your continuous function should be as simple as possible. Like here I took a constant function. See, I solved this question earlier, so I was able to figure out the example, the counter example, or the supporting example much easier. But it may take 5 or 10 minutes to think about examples or counter examples when you are doing it on your own. But practice will make it easy. Okay? So I think everyone got this idea that P statement was saying you have a discontinuous function and you have a continuous function. If you compose the two functions, the resulting function should be continuous. Is it a true statement? Is it possible to say that? We said yes, it is possible to say that if we take examples like this. You can find many more examples like this. Let's move on to statement 2. Your task should be, your homework should be to find 1, 2, or 3 more examples regarding the statement P and Q. So let's take the statement Q. It says that your function f and g both are discontinuous. Try to note that both functions are discontinuous. Okay, both are discontinuous, but their composition should be continuous. Okay, let's try to figure this out. When I was thinking about the solution of this question, I came up with an example like this, and I hope you will find it easy. I took 1 for x equals to 1 and -1 for x not equal to 1. I took fx like this. Okay, and I took gx like this. I tried taking opposite signs in gx. What I did was, in gx, for x equal to 1, for x equal to 1, what I did was, I took minus x. Okay. And I think this will work, let's say.
Ma'am,
And
hello.
for x not equal to 1, yes.
And here also we can give example for this for considering the Dirichlet function also.
Dirichlet function also.
Yeah. Then both the composition f dot g and g dot f will be continuous.
So in both cases you are trying to take Dirichlet function.
Yeah.
So fx can be 1 minus 1 for x belongs to q and x
And
not belongs to q.
you complement.
Yeah. Complement.
And for gx, that's the reverse one.
Just the reverse, exactly. That the same idea was trying to apply on this question. See, the example, the second example here and the first example. My example is discontinuous at just one point, both of these. But the second example is discontinuous at all points. You can take both of these examples. Let's see g of f of x in the second example, what it is. So g of fx. So whenever you take a rational, whenever you take x as a rational, you get fx is equals to 1. And for x equals to 1, this will be 1. For any rational, this will be 1. And g of 1 will be, g of 1 is always minus 1. For any irrational, it will be, what? Any irrational, it will be minus 1. And for minus 1, it is always minus 1. So minus 1, g of f became a constant function. You can do that by your own. You can solve it very easy. So we got two Dirichlet functions, but their composition became a constant function. Similarly here, if we try to do g of f of x, what we will get is, if x is equals to 1, let's say, sorry, x is equals to 1, what will happen? F of x when x equal to 1 is 1. And when you put x equals to 1 in this, it is minus of that. So minus 1. And when you take x not equal to 1, it is minus 1. And so for x not equal to minus 1 in g of x, sorry, x not equal to 1, it is minus 1. And minus 1 comes under this one. So minus 1 is this. Minus 1 is not equal to 1. And for this, you should get the answer minus 1. So this became a constant function minus 1. So this is again a constant function. And you got, continuous. So you took two examples wherein f and g were not continuous, but you were able to prove that their composition is continuous. So that is how beautifully you can construct your own, counter examples or supporting examples. So both P and Q statements here are correct. That means because we were able to support these with the help of our own examples. So A option, which says both P and Q are correct, is only correct. Now let's move on to last example, the most interesting one, I guess. So what I did was to solve this kind of example was to use a very basic approach. Let's see if this works. So S was a set of all those functions wherein those functions were polynomials and these polynomials were satisfying this. You need to find the set S, the number of elements in the set S, cardinality of S, such that the polynomials satisfy this criteria. So if you take any polynomial of degree d, let's say I took a polynomial of degree d. Let's say fx has degree d. So if fx has degree d, then let's say fx is like this. So when you take f of x, what happens? You do this, f of x raised to power d. Then this will be x raised to power d raised to power d. So this will be x raised to power d square. So this will be a polynomial of d square. Polynomial of, degree d square. And this will be a polynomial of degree x raised to power d raised to power 2024. So this will be a polynomial of degree 2024. So I am trying to find the possible value of d. And first of all, my task is to find what is the possible value of the degree d. So let's see, what is it? D times d minus 2024 is equals to 0. So d can be either 0 or can be 2024. So d can be, so I limited my question, which was of any general degree. I limited my question to 2 degrees, 2024 and 0, with this given condition. So let's see if we can further solve this question. So if d is a degree of 0 polynomial, degree d is 0. 0 degree polynomials are constant polynomials or anything else? Yes, constant polynomials or non-zero constant polynomials. So let's say fx is equals to c, non-zero constant polynomials. So if this is given, then f of x will be equals to fx raised to power 2024. Then c, fx here is c. So f of c is equals to c raised to power 2024. And c will be equal to, I hope I'm not making any mistake, is equals to c raised to power 2024. So what is the possible value of c in this case? The only possible value of c you can get is c is either 0 or c is 1. If this is 0, then c is 0. And if this is 0, then c is 1. So c could be 0 or c could be 1. So your fx could be 0 or 1. Or the only constant polynomials could be this. After that, if d is 2024, case number 2. So this was case 1. D is equals to 0. If I discuss with you case 2, d is 0, d is 2024. If d is equals to 2024, case 2, what will happen? Let's say my fx is equals to x raised to power d. That means 2024. Very simple, very simplest example I'm taking. What will happen? f of x will be equal to f of x raised to power 2024. It will be again 2024 raised to power 2024. And it will be this. After that, it should be equal to f of x raised to power 2024, which is equals to f of x, which is this, raised to power 2024. Are they two equal? Yes, they are equal. So that means one of the polynomials can also be x raised to power 2024. What if I take any polynomial? Let's say, let's go very basic. Let's say if I take any polynomial 2x raised to power 2024, what happens? Then f of x will be f of 2x raised to power 2024. So it will be 2 times of 2x raised to power 2024. Okay. Then fx raised to power 2024, the right hand side will be 2x raised to power 2024. Are they two equal? No, they are not equal in this case. They are completely different. Okay, this is 2 extra multiplied in this case. So these are not equal. So this means that this, cannot be the polynomial, can't be the polynomial which satisfies this. Okay. What if I take a polynomial which is like this, x raised to power 2024 plus 1? What if I take this polynomial? Then f of x will be f of x raised to power 2024 plus 1. and it will be x raised to power 2024 plus 1 raised to power 2024 plus 1, right? After composing. And what will be fx raised to power 2024? It will be x raised to power 2024 plus 1 raised to power 2024. Okay. But they are not equal. Are they equal? No, they are not equal. So this cannot be, again, this cannot be the form of my polynomial. Can't be. So you cannot add a constant, or you cannot take a coefficient which is other than 1. So I tried taking coefficient other than 1 in this case, in this example. I tried taking a coefficient 2 in front of it, which was other than 1. In this case, I tried taking an additional constant in this, an additional term in this, which is again not possible. So the only polynomial that is valid in this case of 2024 degrees is this, just x raised to power 204. You can take more examples and you can understand the concept. So the only polynomial that I got was, in case 1, I got these two polynomials, and in case 2, I got only this polynomial. So these are the 3 polynomials I can get for which the condition is satisfied. This means at S contains these 3 polynomials, 0, 1, x raised to power 2024. So this means cardinality of S is 3. And this is our answer. Okay. I think you've got it. If you haven't, now you can take any of your doubts. We are done with the questions for today. Yes. And I'm waiting for your questions, if any.
Ma'am, had not we taken non-zero constant polynomial, so should we consider f of x is equal to 0?
We should not consider fx equal to 0. We should consider. I didn't get your question.
When we are talking about that d is equal to 0, we had said that it is a constant polynomial, but it is non-zero, right?
Mm-hmm.
So should we consider f of x is equal to 0? Like, I'm not sure.
Actually, the thing is, initial idea is to take a non-zero polynomial, because 0 polynomial is considered as a polynomial which is what? A degree, not defined degree polynomial, right? A non-zero constant polynomial is a polynomial that is considered to be a 0 degree polynomial. 0 polynomial is not considered to be a 0 degree polynomial. But let's say, well, let's try to see, after solving this whole idea, which is on the screen, what we got was c to be 0 or 1. So can we take c is equals to 0? That means, can we take the 0 polynomial here? Let's go back to the question and check. So S was a set of all those functions from R to R. Try to read the question again. Wherein f was a polynomial which was satisfying this condition. So if I take f is equals to 0, if I don't solve this question, let's go to very basic. Let's see if this question is being solved by an 8th class student. What he will or she will think is, if they take, very simple idea is, if they take f is equals to 0, does f equal to 0 satisfy this criteria? Yes, because f is a polynomial defined from R to R, and f satisfies these conditions. F of 0 is equals to 0 raised to power 2024. So do you agree that 0 polynomial satisfies this?
Yes, ma'am.
This is one condition, that 0 satisfies this. But I said that we should take fx is equals to c, a non-zero constant polynomial. But I just said this, I didn't mention non-zero constant. Initial idea should be to take a non-zero constant polynomial, because if I take a 0 polynomial, then its degree won't be defined from my side. So from my best efforts, what I should do is, I should take non-zero polynomial. But as I solve, I get to realize that 0 polynomial is also valid. That is the idea that I was going through. Okay, so 0 is valid.
Okay, ma'am.
Okay. Any other question, any other doubts regarding this lecture? Then we can move on to Q&A sessions. I'm also a learner, so don't expect me not to make mistakes, okay? So, and if you have any doubt, you can just ask. I will try to give the best possible answer. Yes, sir. I guess they don't have any doubts. If you can, if you are having any doubts, you can just raise your hands. We have enough time.
Yeah, Unnati.
Yes, sir.
Dear participants, if you have any doubts regarding your preparations, anything, not only related with the questions that we have discussed today, you can ask any doubts regarding your preparations, how to manage your time, that type of things can be asked, because I told you in the beginning that Unnati cleared all these exams in a way with very good rank. So she know how to tackle the situation. So certainly her experience will be beneficial for all of you. And feel free to share your comments about today's session as well.
Yes. Also, you guys please write in the chat box which exam are you preparing for? IT JAM, CSIR NET. Yes, please, Jeeta. You raise your hand.
Ma'am, the first question I missed somewhere. The first question that the changing of the sign.
Can you repeat your question? I'm sorry for not being able to understand.
In the question, you are using the theory that changing of sign within an interval of a function.
Okay. Which question? Okay, let's move on to the question. There was this limit question. Are you talking about the fx/gx question?
Yes, this one. This one.
Yes, please. What is the doubt?
In such question, we have to concentrate on the changing of sign.
Change of sign means what?
Means that
You understand? Yeah,
positive
change.
to negative, negative to positive, that one.
So, what is your doubt?
I have doubt here that when x is non-negative at that time, for any given function, this is a specific functions. These are two specific functions. For any given functions, I have to go through these ideas.
Okay. So your doubt is for any given function, we should follow the same process?
Yeah.
Okay.
Can we follow the same process?
See, in these type of questions, generally we use these ideas. See, in these type of questions where they ask fx greater than equal to gx, fx less than equals to gx, you will find similar questions in CSIR NET. Try to look for these two. See, they ask like this. They will give you fx is equals to sine x, fx equal to x, gx is equals to sine x. And they might ask you fx minus gx is less than equal to 0 or greater than equal to 0, something like that. For these type of questions, you should remember one or two things. Number one is that monotonic function has this property. Monotonically increasing function says x less than equal to y implies fx less than equals to fy. Okay. And monotonically decreasing function says x less than equal to y implies fx greater than equal to fy. The opposite. This says the opposite. Number one. Number second, you should be able to understand that your y should always be comparable to 0. You will always do this kind of things in these questions. You will consider a function hx, which is equals to fx minus gx. And at x equal to 0, most of the times what happens is this hx is 0. So whenever you will find at x equals to 0 the value of hx, this will be f0 minus g0. This will always be, just a second. This will always be 0. Most of the time it will be 0. And so h0 you will get 0. Okay. And you will check for x greater than equal to 0. Is it h of x is greater than equal to 0? Or your question can be, is h of x less than equal to 0? So how will you decide for x less than equal to 0? Your hx is less than 0 or greater than 0. You can decide that by, you can consider 0 to be y here, and you can remember the idea of monotonically increasing or decreasing functions. If x is greater than equal to y, monotonically increasing function says h of x will be greater than equal to h of y. And monotonically decreasing function will say h of x is less than equal to h of y. So when you collect these ideas, you understand that h of 0 was 0. So h of x will be greater than equal to 0 here, or is in this case, h of x will be less than equal to 0. But don't forget what was h of x. H of x was fx minus gx. And you were asked the sign of f of x minus gx only. So in this case, fx minus gx will be greater than equal to 0. And in this case, fx minus gx will be less than equal to 0. So either of these two cases you will be handling while doing these questions. So the main idea is to use this hx kind of thing. And I will share the PDF for this. So don't worry with if you have missed to write something. I hope you've got the idea. I've shared the idea here that we use monotonicity at the first hand while solving for these questions.
Thank you, ma'am.
Okay, dear participants, feel free to share your feedback, if possible with video on mode. And also introduce yourself.
So am I audible?
Yes.
Yes.
Good evening, everyone. I'm 𝕉𝕚𝕟𝕚 and I'm from St. Teresa's College, Ernakulam. So this was my first class. This class was really helpful and I got to know about different types of questions, especially how to eliminate an option and choose the right one. So for me, it was more like an experience on how to attend JAM questions. So that's it. Thank you, ma'am.
Thank you, Rose.
Thank you, Rose. Yes, others.
Sir,
I am Dhanbad from Kasdan.
Yeah. Please. Vandana.
okay. Sir, I am Nandana KM from St. Thomas College, Thrissur, Kerala. And ma'am, it was an effective class for me. And actually, I have joined the Max Aspirants group yesterday only, and it was my first class. And many of my classmates had informed me that the Max Aspirants classes are useful for JAM exams, and not only for JAM exams, but many competitive examinations. So within a short span of 2 hours or 1.5 hours, Unnati ma'am has explained us many important problems in differential calculus. It is very helpful for me. And the class was effective and step-by-step approach how to solve many problems and many difficult problems or the Riemann integrable functions. And it was also without using the definitions how we can approach the question. It is very helpful for me. And I am blessed that I got an opportunity to attend this class. And I am thankful for Unnati ma'am and also Vinod sir for conducting this class. Thank you, sir. Thank you, ma'am.
Thank you.
Thank
Thank
you,
you.
Rachna. Thank you
Words.
so much.
Yeah. Yes, others. Yeah, Dharmendra, you can speak now.
Yes, sir. I am Dharmendra Singh from Kasganj, UP. I am preparing for IIT JAM and other exam also. The session was very nice and each problem was very explanatory. I want to ask about counter example practice. How can we practice the counter example?
So, first of all, the thing is that you have to critically think about examples. Examples doesn't come in your mind at the first hand. First of all, you will read some examples from your books, whatever standard books you are following, or your college books, anything. You get enough number of examples, and then you start making some examples. You can make some functions on your own. This is the second step. You keep making functions which makes no sense or make some sense. You can ask your seniors, your teachers about special qualities of those functions. Depends on your curiosity. And then if you want to go further in deep, try to solve PYQs of different exams which use counter examples. CSIR-NET has many questions related to counter examples. Also, there is one book which is counter examples in analysis if you want to go deeper. It is counter examples in real analysis, something like that. If you ask me, I will send the PDFs if you're interested.
Actually, that book was shared in our group, I think.
Okay. Yes.
Okay, thank you, Dharmendra.
Main ideas too.
Thank you, sir.
Keep on thinking.
Yes.
Yeah.
Okay. Yeah. Yes, others.
Hello, ma'am.
Yeah.
My name is Praveen Casey. I'm from St. Thomas College, Thrissur. Ma'am, today's session was very effective and very interactive. The questions were very insightful. Ma'am, I'm facing an issue with time management, like the exam preparation and also the work with class. So, can you give some suggestions on how to manage them properly?
Okay. So, in which year are you? Second or third year?
I'm in third year currently.
Okay. So this is your final year, and the coming JAM exam should be the serious attempt for you. So I think you should, if you're in college, you should attend the main classes only, because if your college is not very much strict about the attendance, you can miss some classes, and you can utilize that time in doing the college work at that point of time, and just try to fix number of hours in any day, and so that you can focus on your preparation. Just 2 hours for your 2 hours or 3 hours, which you can devote depending on your situation, which is completely it's a personal or specific to you. But try to devote specific hours to your preparation. The most important part of time management is that we are not able to manage our time because we don't give priority to our own goals. If there is a deadline coming up, you will just stay up whole night and you will complete your assignment. But if the deadline is far away, you won't complete that. So it is all about the setting of priority. If you set your priority to the IIT JAM exam and also the college exams, which are also important, so just devote a different set of time for IIT JAM exam and try to do some physical activity, try to eat some good food, healthy food, so that you can stay awake, stay active throughout the day. Because if you keep your lifestyle unhealthy, then you won't be able to, effectively study. You'll be wasting most of your time. So I also believe in that you should be, along with managing your time, you should be devoting some time to your health, your mental health, your physical health, your food. So these are also very important. So don't overlook them. Okay. Your sleep is also very important.
Yes, ma'am. Thank you.
Good evening, ma'am.
Yeah.
Good evening, Archana.
Ma'am, I'm Archana. I'm from PSC Krishnammal College, Coimbatore. Ma'am, I really enjoyed the class. I really like the aspect in which you explained each detail of the question. Like when you went for a question with Taylor series, you explained the Taylor series first and then you went in depth with the question. So that was a really fun part, ma'am. We were able to understand the question better if we were not familiar with that topic. That really enjoyed the class, ma'am. Thank you, ma'am.
Thank you, Archana. Thank you so much.
Thank you, Archana. Yes, others.
Good evening, ma'am. Good evening, sir.
Yeah.
I'm Varada from PSC Krishnammal College, Coimbatore. So I also personally loved today's session. As like Archana told, the best part which I liked about today's class was that you explained each question in detail. Like instead of like giving many questions and like moving on to the next question without much explanation, you only chose like selected questions and like you explained everything in detail. Like basically you focused on the quality and not on the quantity. So, and also I had like many questions that you discussed in, not many, like few of the questions that you discussed in today's session, we had it in during our problem solving session, like our daily problem solving session. And I had few doubts regarding that as well. And I would say that most of the doubt got cleared after today's class. So thank you so much, ma'am, for providing us such an insightful session. And thank you, sir, for organizing it as well.
Okay, thank you, Varada.
Thank you, Varada. So the main idea behind this session was, yes, to get familiar with the concepts. Questions can be many. You can attempt questions by your own. You get the idea on how to solve them. Yeah.
Okay, any others? If any of you would like, yeah, yes, Akita.
Hello, ma'am. I am Akita. I am from TMC College, Tirur. Today's class very nice and interesting. Thank you so much. Thank you so much, ma'am, your valuable time with us, and thank you, Vinod sir, for conducting this class. Thank you.
Thank you, Akita.
Okay, thank you, Akita. Okay, dear participants, feel free to share your comments and ask your queries.
Good evening, ma'am. Good evening, sir. My name is Aditya Das, and I'm from Mahatma Gandhi College, Irati. The session was a very good session. As ma'am, you addressed each and every step of the question in a detailed manner. This was very useful. Thank you, ma'am, and thank you, sir, for conducting this session.
Okay, thank you, Aditya.
Good evening, ma'am. Good evening, sir. The session was really good. I love the session. Thank you, Unnati ma'am and Vinod sir, for organizing this session. Thank you.
Thank you, Nandana.
Yeah, thank you, Nandana. Yeah, Ispida Dasgupta.
Good evening, sir and ma'am.
Good evening.
Yes, I am preparing for CSIR NET. So I prepare the linear algebra, real analysis, calculus of variation, integral equation, LPP.
Yeah, okay. Yeah, Ispida, we have conducted many sessions for CSIR NET as well. You can check our YouTube channel, and these sessions for JAM are equally useful for other exams as well. Only thing is that for CSIR or GATE, there will be more topics, but these topics are also there. Okay.
Okay, sir.
Yes, Veda. Also, I am
Okay.
planning to start some, introductory classes about CSIR-UGC. So all of you who are interested can join. These are just free for, these days, because these classes will be for 8 to 10 days. So these are free. Also, as we saw in today's session, that IIT JAM questions are being, oriented towards CSIR-NET. CSIR questions are being picked up and being quoted in IIT JAM exam. So both of these exams are having similar kind of questions these days. So important for both. Yeah, this session was important for both.
Okay, any others?
Good evening, ma'am. Good evening, ma'am. I am Trishya from St. Thomas College, Thrissur, Kerala. I'm preparing for IIT JAM 2025, and this section was very effective for me. And the way you discussed all the question was very good. And thank you, sir.
Thank you, Drishya.
Okay, thank you, Drishya. Okay. Yeah, Unnati, here in Kerala, in many places, heavy raining is there. So I think many people have some network issues and all that.
Yes, sir. Yes, sir. I understand.
Yeah, in many districts here, red alert is there in many districts in Kerala.
Yeah, that's very good. We are not being blessed with rain yet. We have seen just 1 or 2 rains.
Okay.
Good
So,
for
yeah. So thank you, Unnati, for today's session. And also, yeah, of course, we can arrange more such sessions to explore more problems from different areas in IIT JAM syllabus.
Yes, sir. Sure, sir.
Okay, okay, let us wind up the session here.